Hi again. In this video, I wanted to talk more about measures of spread. In the previous video, you saw one way to figure out the measure of spread, otherwise known as variability, measure of dispersion, or scatter. And we're about on page 36 of your handout or your class notes. So we already talked about two measures of variability on this list. We already talked about range, how to figure out range, and that was your maximum value minus your minimum value. That was the formula for range. Now, range is not very practical and not very accurate in finding the true variability or spread, because if we have an outlier, then we're gonna falsely get a really wide range, when in reality most data values are not that spread that much. Okay, so with range, it's kind of it's very sensitive to outliers, so not very useful for many applications. Now, the standard deviation is the one that we use a lot, and I mean a lot in this course. And that is because, and we use these formulas that look complicated, but we actually, I took you step by step through figuring it out. It looks scary, but it's not as scary when you do them. And for the variance, well, the variance is just the square of the standard deviation. See? You take the standard deviation and square. In the formula, it will look exactly the same, only without the square root. It's before we square rooted our mean square differences divided by n minus 1 in case of a sample, and by n in case of a population. Okay, so that's variance. That's how variance and standard deviation are related among themselves. And then there is another measure of variability, which we haven't mentioned yet. We did it, we saw it, but we didn't point it out. I didn't point it out. So it's mean absolute distance, or MAD. Okay, what is mean absolute distance? So remember this worksheet? That's what we used when calculating standard deviation. And remember how we figured out the differences between the mean and each x value, and they ended up to be, some of them ended up to be positive or values of 0, and some of them ended up negative. And we were talking about how if you were to average them out right now, you would they would average out to 0, because you have equal amount of data on one side of the mean and the other side of the mean. They would average each other out, cancel each other out. But so that's why we said that we're gonna square them to make them positive. However, there is a different way of making something positive, I'm sure you're aware of, is taking absolute value of a number. So the positive numbers would stay positive and negatives would become positive as well. So if we look at absolute value of mean minus x, we would get 9, 8, 0, positive 2, positive 7, positive 8. Now, if we were to average these positive numbers out, so the total is, I have 17, 19, 26, and 34. So 34 divided by however many numbers there are, 1, 2, 3, 4, 5, 6, that would give me the mean absolute average. So for this example, I have mean absolute average of 5.6 that's repeated. So that's the mean absolute average. Now let's take a look at our next measure of spread, which is our interquartile range. That's our fifth measure of spread that we're going to discuss in this course. And again, this is nothing absolutely new that you haven't heard of. You already heard of it, but I didn't point it out when we actually were looking at it. So if you remember our 5-number summary when we did box plots, we talked about 5 numbers, the min, the max value, the median, and then the quartile 1 and quartile 3. So the interquartile range is actually the difference between the quartiles. It's a distance between these two values. So the formula is Q3 minus Q1. That's as simple as that. And let's take a look at one of the examples that's in your notes. Here we have the data set that's case prices in dollars of wines produced by a vineyard in Napa Valley. Okay, so we're gonna find the 5-number summary. Actually, you don't have for the IQR, you don't need a 5-number summary. You just need quartile 1 and quartile 2. But while we're at it, we could find a 5-number summary as well. So as we mentioned, for the 5-number summary, you need minimum value, which in this case is 67, and the maximum value, which is 129. And then we need a median value, and we need quartile 1 and quartile 3. Okay. So if you remember the process, the first step in finding the 5-number summary is to line up your data from smallest to the largest. And my smallest number here, as I mentioned, is 67. That's what we're going to start with. And then the next one is 90. So that's below 100. I have only 2 numbers. And then I don't have anything in 110s. The next would be 120. So I have I think 122 is the lowest one. 122, and then I have 127, and then I have 2 128s, and then I have 129. So that's it for 120s. What about 130s? I have 132 and 135. So 132, 135, and then I have in 140s, I have 2 140, 2 values of 140, and then I have 142. That's it for 140s, and 1 value of 150 in 150s. Okay, so now my data is arranged. In order to find the median, and remember we were talking about the formula that will help us to locate the median. So location of the median. And the formula was n plus 1 over 2. So we need to know n. Okay, so we go in and just count our data values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n is 13 for this data set. All right, so we're going to have 13 plus 1 over 2, that's 7. All right, so this is not our median, that's the location. So we have to go into our value and count number, value number, grab value number 7. 1, 2, 3, 4, 5, 6, 7. Here it is. So that's our median, 129. Okay. Now remember that our median, it actually divides our data into two equal pieces, 50% below and 50% above the median. Actually, it's vice versa. All right, so now in order to find quartile 1, I'm gonna do the same thing. I'm gonna find the median of this string of numbers. Now I have only 6 numbers, so I could tell that it's between value number 3 and value number 4. Okay, but if you don't know that, then go through, use this formula, do 6 plus 1 divided by 2, and you get 3.5, which is between 3 and 4. Okay, so when you average out 122 and 127, you get 124.5. And then you do the same thing on this side, and I see that I forgot one data value here. I only wrote 140 once. I need to correct that. There is another 140. All right, because otherwise we have only 5 values on this side, not 6, and that cannot be. So you following the same logic as here, we're gonna grab the value between the 3rd and the 4th value, and that's gonna be our Q3. Well, the value between 140 and 140 obviously is 140. All right, so here's our 5-number summary. Well, let's go back to our IQR. So IQR is basically the distance between these two values. It's the distance between quartile 1 and quartile 3. Okay, so how do you find it? Well, you grab Q3, 140, and you subtract Q1 from it, 124.5, and you come up with 15.5. So that's your IQR for this data set. Now this IQR works really well for data with outliers and for data that's skewed. Why? Because it doesn't look at the bottom 25% of the data and the top 25% of the data. It only looks at the middle 50%, so, which will cut out outliers. So outliers are usually, well, not usually, they're always at the very ends, either the bottom end or the top end or both. So by cutting the bottom 25% out and top 25% out, you're cutting out outliers, so they really don't influence your range as much. As opposed to standard deviation, everything gets calculated in, including the outliers. So it's sensitive to outliers. And this measure of spread is more resilient to outliers and skewed data. All right, so another one more piece that I wanted to look at here is when to use. So we actually looked at 4 different measures of center and 5 different measures of spread. So which one are we going to be using here? So for symmetric data or normal data, you're going to use, for the measure of center, you're going to use mean. And for the spread, you're going to use the standard deviation. All right, for symmetric data. For skewed data or data with outliers, what you're going to use median for the measure of center, and you're going to use IQR for the measure of spread. All right. Please remember this, and this is it for now.